Now let's start with class number 7, sequences and series for the IB mathematics standard level. Sequences and series, we have two main forms of sequences and series. The first form is the arithmetic sequences and series. Sequences and series. The difference between a sequence and a series is like in a sequence, if I have two, let's continue in black, 2, 4, 6, 8, and so on, and I'm not adding these numbers, this is considered to be a sequence. If I'm having it this way, if I have 2 plus 4 plus 6 plus 8 plus whatever, this is called a series. That's the difference between a sequence and a series. A series is when I'm adding the numbers. A sequence, only I'm having a sequence of numbers, but I'm not adding these numbers. So, if we want to start with arithmetic, this is a very good example to start with. I'm having a 2, 4, 6, 8. Here, I'm having a fixed difference, because here I'm adding plus 2, and this is another plus 2, and this is another plus 2. I'm having a common difference. When I'm having a common difference between terms, then it's considered to be an arithmetic sequence, an arithmetic sequence. So to test for an arithmetic sequence, if I'm having, let's say, this is my first term, this is my second term, this is my third term. If I'm having U3, which is the third term, minus the second term, which is U2, is equal to U2, which is the second term, minus U1, which is the first term, are equal to each other, then it is an arithmetic sequence. Let's check. U3 is 6, minus U2, which is 4, is equal to U2, which is 4, minus U1, which is 2. So 6 minus 4 is a 2. 4 minus 2 is another 2. 2 is equal to 2. So we can consider this as an arithmetic sequence. To find any term for an arithmetic sequence, we can call it the nth term. The general rule for finding the nth term is U of n is equal to U1, the first term, plus n minus 1. N is the number of terms times d, where d is the common difference and U1 is the first term. By this, I can find any term for an arithmetic. This is an arithmetic sequence. This is what I have for a sequence. If I want to go for the series, like I'm having 2 plus 4 plus 6 plus 8 plus blah 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 till I reach my nth term, whatever my nth term is, to find the sum of all these numbers is really important and essential. So the rule for finding the sum is either S of n is equal half n, which is the number of terms, times 2 times U1 plus n minus 1 times d. Or, if we know the first and the last term, we can find the sum by S of n is equal to half n times U1, which is the first term, plus L, which is the last term. All of these formulas, this one finding a sequence. This is the first formula. This is our first formula to find any term within the sequence. And these formulas, the second, for finding the sum, you can find them included in the formula sheet. So you don't have to worry to memorize. It's just you have to know how to use them. This is for arithmetic, sequences, and series. The second type of sequences and series is the geometrical sequences and series. Is geometrical sequences and series. For the geometrical sequences and series, I'm having a common ratio. Like I'll have 2, then the second term is 4, and the third term is 8, the fourth term is 16, and so on. So I'm having this is as my first term, this is my second term, this is my third, and this is my fourth term. Here for this sequence, I'm multiplying each term by 2. I'm multiplying each term by 2. So here I'm having a common ratio. I'm multiplying each term by a common value, which I call it a ratio here. I'm multiplying by a common ratio, which is 2. So to find any term, I have here u, nth term, is equal to u1, which is the first term, times r, which is the common ratio, to the power of n minus 1. R here is the common ratio. R is equal to the common ratio. Also, to check if a sequence is geometrical or arithmetic, in the case for the geometrical sequence, if I divide the third term by the second term, it must be equal to the division of the second term by the first term. If this condition is applied, then the sequence is considered to be a geometrical sequence. Let's go to u3, the third term, which is an 8. This is an 8, divided by the second term, which is a 4. Is it equal to the second term, which is a 4, divided by the first term, which is a 2? Then I'm having 8 over 4, which is a 2, is equal to 4 over 2, which is another 2. I hope it's clear. This is my first rule to find any term of the geometrical sequence. Now, for the geometrical sequence and series, we have 2 types. For the geometrical sequence and series, I have 2 types. The first type, we call the sequence divergent sequence. I'm having a divergent sequence. We'll take an example. And the second type is a convergent sequence. Let's start by the divergent sequence. The divergent sequence or series, I'm having the absolute value of r to be greater than 1. Why? Let's see our first example, the 2, 4, 6, to 2, 4, 8, and 16. If I'm having a 2, and here is the common ratio is 2, then 4, then 6, then 8, and 16. If I go to infinity, I'll have an infinite value here, because the values are continuously increasing because the common ratio is greater than 1. So we call this type of sequence divergent. this type of sequence divergent. Let's go to the second type, which is the convergent geometrical sequence. Convergent. The convergent geometrical sequence, I'm having the absolute value of r is to be less than 1. Let's take an example with r is equal to half. Let's start by 2. Then I have multiplied by half, it becomes 1. Times half, it becomes half. Times half, it becomes 1 over 4. Times half, it becomes 1 over 8. As we go to infinity here, the values will approach the 0. So we call it convergent. Now, to find the summation of any geometrical series, sum to n is equal to, I have u1 times r to the power of n minus 1 over r minus 1. Or I can have it the opposite way. Sum of this series is equal to u1 times 1 minus r to the power of n over 1 minus r. This is for any geometrical series. Either it was convergent or divergent. But the different thing for convergent series, if we want to find the sum to infinity for, this is sum to infinity for convergent series, I only have to apply the infinity instead of the n. So for a convergent series, this is so essential. If I want to find the sum to infinity, it's equal to u1 times 1 minus r to the power of infinity over 1 minus r. In this case, the r to the power of infinity, it gives me a 0. Why? Because it's a fraction. So it's the reciprocal is 1 over r to the power of infinity, which is 1 over infinity, which is equal to 0. So the sum to infinity for a convergent series only, the sum to infinity is equal to u1, which is the first term, over 1 minus r. And also this rule, since we have this is the second one and this is the third one, we can find also this rule in the formula sheet. For a divergent series, the sum to infinity, we can't find it. If r was positive, we can find it. Otherwise, we can't. It's also really hard to find, maybe because if an alternating sign, like if I'm having minus 1 times, if I have r equal to minus 2, let's say, so I'm having alternating signs. So it's really hard to find the sum of infinity to divergent series. For convergent, of course, we can, and this is included in our course. Only the sum to infinity for a convergent series. Otherwise, for a divergent series, only we can find the sum of nth terms. Now, we've talking about arithmetic sequences and series, how to find the nth term, how to make or to prove it's an arithmetic sequence. I have to subtract the terms from each other and find the common difference, and I find the sums of nth terms. For the geometrical sequence and series, we did the same. We have two types, divergent and convergent. For the convergent, we can find the sum to infinity. And all these rules are found in the formula sheet. Let's now solve some examples from the question bank. Example 1. This is an example on an arithmetic sequence. In an arithmetic sequence, the first term is 3 and the second term is 7. So to To start with, I'm having a u1 is equal to 3 and u2 is equal to 7. Find the common difference, part A. The common difference is really easy, is equal to u2 minus u1 is the common difference, so is equal to 7 minus 3, which is equal to 4. Part B. Find the nth term. Simply, we use the rule. We have here now, the common difference is equal to 4, and we have u1 to 3. So I use u of 10 is equal u1 plus n minus 1 times d. N, which is 10, minus 1 times d, which is the common difference, which is 4. So u10 is equal to u1, which is 3, plus 9 times 4. So it gives me 3 plus 36 is 39. This is the 10th term. Part C, find the sum of the first 10 terms of the sequence. I need part C, S of 10, which is equal to u. I use my formula, which is this one. Half n times 2u1 plus n minus 1 times d, which is half n times 2u1 plus n minus 1 times d. So S of 10 is equal to half times 10, open bracket, 2 times 3, plus 9, which is 10 minus 1, times the common difference. The common difference, I have it as a 4. So it's equal to 5 times 6 plus 36, which is 42, which is equal to 5 times 42 is 210. As 5 times 40 is 205 times 2 is 10. This is the sum of the first 10 terms. This is for example 1 for the arithmetic sequence. We can go now to solve a question on a geometrical sequence. So example 2. In a geometric sequence, the fourth term, the 4, which is u4, is 8 times the first term, equal 8 times u1. The sum of the first 10 terms, S of 10, is equal to 2557.5. And the question wants to find the 10th term of the sequence. The question wants to find the 10th term of the sequence. We have to get use of these info to find the 10th terms. So now, u4 is equal to 8 times u1. u4 is equal to what? u4 is equal to u1 times r to the power of n minus 1, which is equal to u1 times r, n which is 4, minus 1, 3. This is what u4 is equal to. So I'm having now, I can substitute this value instead of u4. So u1 times r cubed is equal to 8 u1. Over u1 over u1, the u1 cross out. Now I'm having r cubed is equal to 8. So r cubed is equal to 2 cubed. So now I find the common ratio to be equal to 2. This is my common ratio. I hope it's clear how we found the common ratio. Now we need to apply an S of 10 to find u1. Let's start. So S of 10 is equal to u1 times r to the power of 10, which is 2 to the power of 10 minus 1 over r minus 1, which is 2 minus 1. And I know that s of 10 is given by the question, which is this value. So I have 2, 5, 5, 7.5 is equal to u1 times 2 to the power of 10 minus 1 over 1. Simply, I have to divide by 2 to the power of 10 minus 1 here. So I can find u1 now is equal to 255, 7.5 over 2 to the power of 10 minus 1. Now I need my GDC. Let's do this value. I have, this is on, 255, 7.5 divided by 2 to the power of 10 minus 1. So I'm having u1 is equal to 2.5. So now u1 is equal to 2.5. I found by this u1. Now, after knowing the first term and the common ratio, I can find the 10th term. Because for a geometrical sequence, we've said that un is equal to u1 times r to the power of n minus 1. So u10 is equal to u1, which is 2.5, times r, which is 2 to the power of 9. So u10 is equal to, can use our GDC as well, brackets 2 to the power of 9 times 2.5. It's equal, the 10th term is 1280. So u10 is equal to 1280. This is my answer. I hope we've covered everything. I hope the examples are useful, especially this example. It's really essential to be smart dealing with such examples. You have to take it easy, and you have to be capable of analyzing the question and just solve it step by step, and everything becomes clear and easy at the end.